So Casey has been working with some new Forstner bits we bought on recommendation of the internet. And this is not going to be a dig on the people who recommended it. That's the holes they produce. Obviously, this is your spade, or not spade bit, your paddle bit that we have on there. And that's the very unclean hole that produces. However, take a look at these holes that we drilled in the plumbing. They're very neat, tidy. I mean, what did you think about them, Casey?
The Forstner bits?
Yeah.
They're a nice bit, but they take a lot of effort.
Yeah.
A lot of holding the bit for going through a 2x6.
Yeah, just
Take that long.
just dimensional lumber, and it was taking quite a bit of time to cut in these, a couple of holes. So we just decided, this is the Forstner bit she has on there. Are you going to cut another one?
I'm just going to clean up the paddle bit hole.
Okay.
See if that will work.
Yeah. So one of the things that's going to make this process easier is if you have really nice, smoothly bored out holes. I just got to get over to here and then down into the panel, so that's probably enough. So this guy right here is a good example of a hole where the bit came through and, really was pretty rough. And it's left some jagged pieces here, which is what you're trying to avoid, or at least I'm trying to avoid, so it doesn't cut up your Romex when you're passing it through these spots. Here's an example of a hole where we got a much cleaner entry. This is not the exit, this is the entry. But this is what I would like them all to look like. So I've tried out the 5 main kinds of bit for drilling electrical holes and plumbing holes. This is a hole saw bit. They produce fairly fast, reasonably fast, very nice and clean entry and exit holes. But they don't work well in this gauge. It can be very hard to get the chuck that gets stuck in here, the wood piece, out of the bit. And on smaller gauge holes, these Forstner bits, the only downfall is that they can be very slow. Paddle bit and the twisted bit produce very fast cuts. They will go through quite quickly, which is nice. So that's the positive versus the Forstner bit that I already showed you. However, they produce fast cuts that tend to be very, very unclean, very jagged edged on both the entry and the exit. This bit will usually produce a clean exit, and sometimes it will also produce a clean entry. So these are my favorite for drilling electrical right now. No. 2 days worth of eggs from our ladies. Kind of the start of the growing season. This is our Polonia we planted. You guys can help me track it over the course of the year and see how much it grows. But right now it's just getting its leaves out. Just like the maples, over the next week or two, these will all be coming all the way out. They're going to be huge. Good. I'm glad to hear that worked out much better for you. All right, so we have our panel installed, and this panel is a square D panel. You can see that I've got a large bank usable, and that's just so that I can, have room on pretty much any of my circuits to be able to continue to add fixtures and have plenty of room and have no question as to everything being code compliant. We went ahead and installed it to where the top breaker does not exceed, I think it said 6'7" in the NAC, so that's like up here-ish somewhere. So we're below that for all of ours. We are running our power's coming up from below to the box, and so the breaker is inverted compared to how you would normally see it. And almost everything we're going to be taking up and shooting out through the house that way anyway to get where it's going. So Casey's working on the first strand of wire.
You have to staple within 8 inches of the box, And so sometimes that means when you drill your hole, I drilled it up here, and because I didn't drill it far enough above the box or below the box, I have to wrap it, and it might be better to come get an angle over here. I have to wrap it around in order to be able to staple it, because I can't get in there to staple it right next to the hole. And then also bend it to get it into the box. So I'm taking it down past the box, stapling it, and wrapping it back up, which gives us a little extra wire if we ever need to have it for any reason, but probably isn't the best use of our wire. So when I do it again, I will make sure to run it low enough that when I come up, I have room to staple and then run it directly into the box, which will save me, 10 inches of wire or something.
Yeah, and the reason that we were kind of in that mode was because over here, there's an obstruction. So you have that giant metal bracket, and so we kind of just started drilling the holes high, and then really realized that it was going to have an impact in that fashion. So just a little tip: make sure that you think about the stapling. Casey's been running wires, getting everything ready. We only had a handful of staples left over from the shop, and I think that's something that is in the package that I bought and that had not arrived yet. So we have our service cable pulled up into the house, and we don't have the clamp yet. I forgot about that. Big enough to take this guy for the punch out right here. So we're gonna wait on pulling that in, and I gotta find something that I have that will actually cut this. I think maybe I have a bolt cutters will probably do the trick. This is all kind of plotted in, and we got the ground bars installed. And we got the breakers -1, all ready to rock and roll, and the panel is set. So this is our service entrance wire. It's 4040 4020. Honestly, this was the only one that we could really find that was going to work for us at the time when we bought it. Copper was just insanely expensive. It had really spiked. So we're getting ready to pull this up into the panel. I do have a couple feet of extra. Question I'd had though is with aluminum being so much larger than copper, those are just so large. Was it going to fit with a standard clamp? And I have here a 2-inch, which is the largest that at least is sold locally for this style of clamp. And it barely does, but it does fit at the maximum extension. So we've already knocked this out just with your standard punch or screwdriver. And we went to the 2-inch size, basically just put this on here to see which of the rings needed to go, and it was this one. So we're gonna tighten it, down here on the bottom with these screws. And then up here on the top, I'm just gonna see if I can grab that. Just gonna push these little tab things on the sides with this screwdriver flat. Hope I don't injure myself there. We've got pretty good compression on that now. So obviously the first thing we're gonna have to figure out is how much of this needs to be cut, because this is way too much. So I'm gonna give myself enough to run a loop inside. So I'm gonna go ahead and try and cut it right around here. And I'm gonna mark that off. Next question is, can I cut this with a bolt cutter, or am I gonna need something bigger? I think this is about as fat as that can take. We'll find out though. There's 2. Okay. Get these extra sections out of the way here. We're going to try and get these threaded up through. We've got our great big old bolts here. I gotta see if I have a Allen wrench that's large enough to handle these right here. So this is not the right size of Allen wrench by a hair, but that's okay. I can get it to start far enough in there that I can work these out, but I am gonna have to get the right size of onto these in order to really get them as tight as they should be. This just doesn't have enough grab. I suppose I could file it down and have it fit in there because it's really close. One of those US versus metric things maybe. I don't know if this one says what it is anywhere on it. Doesn't look like. One of those tools that I've just had forever and I didn't know if I'd ever use it, but just kept it in the set. So we're going to try and take these cables, and there's a little bit that went down to the floor, so I'll pull some up through. You know, they're going to be hangered down there, but if you ever needed more, you would be able to just rearrange how those are hangered. There are tools for this. This is not the right tool for this, in case you're wondering, but there are tools that are for this job specifically. I don't have any electrician friends, and I don't have an electrician business, so I do not have those tools. There we go. This will just go up in here. I'm really hoping it will. So it's going to seat in there like that. And then for now, I'm going to try and get this wrong sized Allen wrench in here to secure this as best I can. All right, done what I can there. So we got our neutral. And you can, if you're ever confused about what these are, you can just trace them. So this is your neutral bar on the other side. I've installed 2 grounds in case I need them. So it's a big panel, probably don't, but went ahead and did it for convenience. You've got your power, and it is running up, and you can see the plate joining all of these together on the back of these 2 lug nuts. So, well, not lug nuts, these 2, I don't know what these are called. If there are any electricians out there who are watching this, you'll tell me all the things I'm doing wrong, which is good, because I need to know, but also because I don't know what the terms are for these. Trying to remember to cut away from myself with this thing. So we used to have, I used to work in retail, and we used to have an associate who had a really, really good box knife blade. And they were really proud of it. There was some special company that made it that they had a connection to. This person was basically just doing it as a thing to do to get out of the house. Like they had a car that an associate at a retail store would not have otherwise. Retired from the service, I think, if I remember correctly, the Coast Guard. And this blade it was a nice blade. The company went from allowing personal blades to requiring a specific company design blade that was safer. Supposed to be a really, really good design for safety, and it had its upsides to it. Just trying to get this to split on that cut line. Once it's done that, it's easy to peel. There we go. And this guy, when I was in charge of the safety for the store as the assets protection and HR guy, and yeah, that was a thing. The company had me in charge of both. You'd think that'd be a conflict of interest or something, but there you go. So I was in charge of safety. I'm gonna have to back that out just a hair more, I think. And this guy did not want to give up on his blade for one of these new blades. Well, he kept using it even after being told not to, and then ended up cutting himself pretty bad. And we discovered that he'd been sneaking this blade still and was not using a company approved blade. Well, you can guess what happened. His insurance claim got denied. So I always try and be a little bit careful with these. Okay, that's about as stiff as that can get. Let's go ahead and double check this one. That's where we started from. Make sure we're good here still. All right, I'm gonna go ahead and Tighten this up just a little bit. All right, that all feels very stiff. Now, obviously with panel work, you don't want to be doing this if this is live. These wires aren't even connected at the meter box panel. So I'm going to be able to do all this work until I decide I want to energize this without having any possibility of getting myself killed. So I don't like messing with these if there's a possibility, just because, you know, if you touch a small wire in a box, it's going to hurt. Give you a little surprise for sure. But, you know, if you do a larger gauge wire, you could really hurt yourself or kill yourself on one of these contacts. So,
Mom, I will play ball. Okay, we'll do that.
So the loop that you can leave of wire, is that right next to the box that you can leave that? I might leave a loop over here somewhere, so that if I do need power for something else in this area, we can do that, because I've got
I do
extra.
think it is the box. Yes.
Yeah,
I think it
okay.
has to be in the box.
Okay. I just had to cut so much extra because I wasn't exactly sure, because I didn't have the staples.
Yeah.
So I won't do it too much. Like, it won't be my default way of running wire. So when you're stapling wire, one of the more important things to keep in mind is the rest of the design of the house, because you have to make sure you're not putting anything in the way of anything else that you're gonna have to rip out later. So when you, like in this spot, I have to keep in mind that there's a 2x4 wall here, so this actually isn't a 2x6. So everything that I staple has to be way to this side, but still leaving enough clearance to meet code there. And you want to make sure that your wires are pulled into the center of the wall so that there's the least chance that they might get hit with something. And so you just have to kind of work the wire and kind of turn it and flatten it and make sure it's going to sit where you want it to sit after you staple it, so that it's out of the danger zone. There's a similar thing in this section. It would have been a shorter run to pull the wire through this hole and down here along this wall, but I happen to know that we're going to put a additional 2x6 here in order to be able to mount curtain rods on the side of the window here. And so if I had pulled the wire over here, we wouldn't have been able to put that nailer there, and it would have caused us some problems down the road. So what I'm doing here, because I have just a little too much wire because we didn't have staples, so I left a little extra. Basically, I'm just leaving a little extra in the wall. So I'm going to staple it down here, and then I'm going to loop it up underneath the box. So I chose to bring this wire over even though there's a little more wire used, because I don't know what the nailer situation is going to look like on here, because in order to attach the sheetrock, I may need to do stuff in this corner, and I don't want the wire to get in the way, so I just brought it over
Head up this way.
You can definitely add wire staplers to the list of things I would have loved to have had for this project. Unfortunately, like so many other tools, I have to restrain myself from getting them because they're just not in the budget for this. And it doesn't really make sense if you're only doing one house to invest in a lot of specialty tools. And that's all we're doing is just this one house. So one of the main design considerations that I have for electrical, where I'm running the home runs to and where the wires between each of the boxes is going to be to keep it within the heated envelope of the building. Another one of my considerations, and I'll show it to you here, is that I don't want a lot of crisscross and I don't want a lot of catty corners, and I want to pay attention to how I'm running the wires wherever there's going to be insulation. I am the one who's going to be doing the insulation. And I want it to be good. I want this house to be, as much as it can be, well insulated. You know, we're gonna be putting in thick insulation in the ceiling here. So I'm running where I can along the beam, running where I can along the joists. And wherever I can, I will do that. And there's not gonna be a bunch of crisscross applesauce getting in the way of the insulation. It'll just be tight to the sides, tight to the studs. And so you won't lose much of that. I'd like to take a home run one wire a ways and then branch it off and have it be efficient and not waste a bunch of wire, not make a bunch of holes in the structure. Fewer holes, in my opinion, is a good thing. Less wire is a good thing. So I am making more holes through interior walls than I am through exterior walls, but let me show you an example of one of the things that we're doing with this panel, and then we'll look at it in the home run as well. Oftentimes I will try and take loads that are going to be pulling at the same time and put them onto opposite bus bars and just roughly balance out what the load on each of these bus bars is. I don't know that that's something that is really that important in residential, but I've heard that it is something to consider, so I'm considering it. So an example of that would be you have your laundry plugs for the washing machine on that side and the dryers over here. The dining, which is going to get used at the same time a lot of the time as the kitchens. They're on opposite sides, and so is the laundry. So that kind of balances that out. And then another would be, we'll have the stairs and foyer plugs on the one side. They won't get used very much, but the laundry room and office plugs will be on the other side. So if you're like me, a homeowner, you might be wondering what the difference is between a 250-foot roll of Romex and a 1,000-foot roll of Romex. Price difference, actually very, very, very negligible, at least at the major retailers. So Lowe's, Home Depot, it's within a couple of pennies for this 1,000-foot versus the 250-foot rolls when you add up the four that it would take to get to 1,000. What the other difference is, though, is that if you want your wire to be nice and straight, easy to staple, not curve a whole bunch, harder to pull, then you want it to come off of your roll straight. And there are ways you can do that by walking it out. You can get a spinning jenny. At least that's what they call it in fencing. I'm not sure if it's the same in electrical. And you can also, buy these larger rolls. That is the one advantage I see. However, they are very heavy. I'm pulling off of one side. And if you simply have a block piece of wood, you can secure that down, and then this thing's just gonna butt up against it, and it will pull off of that piece. I'm going through that hole right now, but it's gonna pull off that roll and stay nice and straight. So that's just an easy way you can get one of these big rolls set up that you can't do with one of the 250s. But I can get these nice and flat because I never twisted them a bunch, pulling them off of that spool. So it's going to be very easy for me to be able to get these secured in a way that is productive, I think. All right, so I'm really not good at this one, but obviously, just like we were talking about before, I'm gonna run, this one's a light wire. And you start to pull this off and it's gonna be this, you know, slinky, basically. So what you wanna be able to do is you wanna be able to put it kind of away from you. You know, it's gonna start that way. Thanks for watching. Hit the subscribe button for more, and if you enjoyed this video, please give us a like and leave a comment. It really helps us out a lot. These videos take hours of our time to make, and once we hit 1,000 subscribers, YouTube will start sharing their revenue with us. See you next time.